Alright, here's our Math 3 test benchmark review. So let's take a look at it. As always, I would use this, I would take the test first and then use this to kind of check your work and see if you're ready to go, or study it up right before the test to make sure you're ready to go on these problems. So the first one, it wants us to solve this equation, v equals s cubed for s. So we've got s cubed, so what would we do to undo s cubed? Well, we'd take a cube root. So we'd have the cube root of the volume equals, those cancel out, side squared, and that's all we need to do. On number 2, we say solve for the equation c equals the square root of e divided by m, and we're solving for e. So first thing we need to do is get rid of that square root. So the opposite of a square root is squaring, so we square both sides. So I end up with c squared equals, those cancel out, e divided by m. So we times both sides by m. So I get m times c squared equals e, or e equals mc squared, which is usually how you see it. Okay? Now number 3 is a little bit more complex, isn't it? But same idea. We want to get b2 by itself. So first I should notice that I'm multiplying by 1/2 in the h. So if I times both sides by 2, that would get rid of my 1/2, and I'd have 2a equals h times b1 plus b2. Then to get rid of that h, we want to divide both sides by h. So I get 2a divided by h, not 2 again, equals b1 plus b2. Then my last step would be to subtract the b1 from both sides. So I'd end up with 2a over h minus b1 is equal to b2. And that's what my equation would look like. Okay, so those were just kind of doing that, solving for a different variable, which is what we use in inverses. Alright? Okay, so now, because this is on inverses and transformations, let's look at how they've been transformed. So remember, the main thing is a times x minus h plus k. K is affects going up or going down. H affects going to the right or to the left, and it's opposite. So a negative h goes to the right, positive to the left. Okay, write that down if you need to. Whereas k, positive goes up, negative goes down. Now a, that's the tricky one, right? A affects a few things. If a is negative, it's going to reflect it. Okay? If a is between 0 and 1, positive or negative, 1, it's going to do a horizontal stretch. And if a is bigger than 1, or smaller than negative 1, it's going to be a vertical stretch. Okay? So first thing to do, figure out what a, h, and k are. So the k is the easiest. It's outside whatever is happening. So it's negative 4. So that means we're going to go down 4. The h is on the inside, and it's opposite. So a plus 5 is actually a negative 5. Okay? So a plus 5 would go left 5, and a negative would go right 5. Minus 5 would go to the right 5, I guess I should say. And then a is negative 1/3, so that negative tells us it's going to reflect over the x-axis, and it's going to have a horizontal stretch of 1/3. Okay? And that's all you needed to do on 4. So 5, same idea. Okay? Got an a here of 5. So it's not negative, so not reflected. It's bigger than 1, so we have a vertical stretch by 5. Okay. Then, if we look on the inside, we have a minus 7. So we're going to say we shift to the right 7. And then finally a plus 2 on the k. So, and shift up by 2. Okay? Now number 6, we're kind of working backwards. It says a function f of x equals x cubed has been reflected across the x-axis and vertically stretched by a factor of 2. Shifted left 1 and up 3. What is the equation? So let's find our a, our h, and our k. So we've got a reflection and a vertical stretch by 2. So a deals with those. So it's reflected, that makes it negative, vertical stretch of 2, negative 2 for a. Then shifted left 1, so left would be a plus 1, and up 3 would be a plus 3, and it's a cubic. So I go f of x equals a, parentheses, x plus h in this case, right, minus h, and then cubed, and then we're going to go plus 3. Make sure you get that function aspect of it in as well. And there we go with those ones. Okay, so first 6 problems down already. Alright, now let's take a look at number 7. Here we are at number 7. Mr. Rydalch has lived his whole life in the Twila area. He has suffered contamination by the chemicals that the Twila Army Depot has been releasing since before he was born. Due to the change or mutation in his physiology, Mr. Rydalch now has a superhuman strength that grows as he gets angry. The THS Math Department has determined that the increase in Mr. Rydalch's strength follows this formula, f of x equals 1 times 5 to the x, where x is Mr. Rydalch's anger level, and f of x is the number of pounds Mr. Rydalch can bench press. How angry does Mr. Rydalch need to be to bench press 1 ton, or 200,000 pounds? Okay, so the idea here is to understand that when we're looking at this, okay, x is the anger level, and f of x is the number of pounds. So this f of x is what we have. Essentially, f of x equals we'll do just 2,000 pounds. Okay, and so that's equal to the 1 times 5 to the x. Okay. Now, that's the tough part. How do we figure out what we've got here? Okay, because it's equal to, so we want to go back and find x. Well, if we can find the inverse of this, that'll work backwards, right? So if I go find the inverse, okay, so remember when we were doing some of our problems, we found that those exponential equations, their inverses were the logs. So we have log base 5 of x. Okay. Now the thing to note is because with inverses we swap the x and the y value, the input here would then be the output of the previous, and the output of our original is the input of our inverse. So we want to actually find out what this would be at 2,000. Okay, so to do that we actually end up using a calculator because that's really the easiest way to do it. So you just type it into a calculator, or you could even graph it on Desmos and work backwards, or do whatever you have to, okay, to get that figured out. So but you type that into a calculator, and you get about 4.7. So okay, so I'd have to be 4.7 anger levels, I guess we could call those. So once again, the idea here is this is the input of that x to get the output. So on my regular function, the 1 times 5 to the x, my point would look like this. But we were given the output, so if we find the inverse, we can then use the inverse as the x value, and then we use that inverse to find the y value, the output. And so that idea of swapping the inverses, the x and y, very useful right here. Okay. All right, number 8. For the functions below, describe the series of transformations that would map f of x onto g of x. Okay. So if we start with this parent function, which really isn't I mean, it's a piecewise function, but not really much more to say about that. Okay, so we need to find the A, the H, and the K. So, A, the first question we want to look from f of x to g of x, does it look reflected? Well, this starts down and then it goes up, okay? This here with that. So I'm going to say yes, it's reflected, so I know that my A is negative, okay? But a reflection would actually move it right about here, wouldn't it? Okay, if I just reflected it exactly, it would look something like this. That's just what a reflection would be. But it's more than that because it's also been bumped up, hasn't it? But if I notice, this point, this one hasn't been moved, and that one hasn't been moved. So I haven't shifted it at all. So my H is 0. But my K, it looks like it's moved up to right here. So that would move it up 2, so my K is going to be positive 2. Okay, then it would have looked up, been that big and that big. Okay, but notice instead it goes like this. Okay, and it goes like this. So if we can look at this slope, that can help us. So this slope is negative 1 over 1. This slope right here would be down 1, 2, 3, 4, to the right 2. So negative 4 over 2, which is negative 2. Okay, if we look at this one, down 1 to the right 2, so negative 1/2. This one down 2 to the right 2, so it would be negative 1. So we go from negative 2 to negative 1, and we go from negative 1 to negative 1/2. So hopefully that's pretty easy to see that how is our A growing? By a half. So it would be negative 1/2 for our A. So in words, we would say reflect over x-axis, and remember when it's in between 0 and 1, or 0 and negative 1, like negative 1/2, it's a horizontal stretch of 1/2. The reflection takes the negative. Then there's no right or left shift, so then it shifts up 2 units. Okay? And in function notation, we would go g of x equals negative 1/2 f of x, because there's no h, so you could put a minus 0, but you don't have to, plus 2. Okay, kind of a difficult problem, but that's what it would look like. Okay? All right, now we want to just find some inverses. So, remember, first step, change f of x to y, then swap the x and y out, so we get x equals 2y minus 5. Then we solve for the y. Now normally, if we knew what y was, we would start by times and by 2, subtracting 5. We're going to do the opposite, okay? So if you really need to, write that out. Say first, if I started with y, I would times by 2, then subtract 5 using order of operation. But I'm solving for y, so I go backwards. So I start out by doing the inverse operation in backwards order. So I add 5. So we add 5 to both sides, giving us x plus 5 equals 2y. Then I'm going to do the opposite of times by 2, so I divide by 2, and I end up with x plus 5 over 2. Now, I can split that up. That 2 can go, and I could rewrite it as 1/2 x plus 5/2, or even as x over 2 plus 5 over 2, or I could leave it as the x plus 5 over 2. Any one of those three would work. And I guess if it's a multiple choice, depends on how they put it in. Okay, looking at number 10. Same idea. Change that to a y, swap x and y, end up with x equals 3 times the cube root of y minus 5. So again, what is happening to y? Well, first I would deal with inside the square root. So first we'd go y minus 5. Then I would take the cube root. Then we would times it by 3. So going in reverse order, I start by dividing by 3 first. Okay. Then the opposite of a cube root would be cubing. Then we'd add 5. So we start first by dividing both sides by 3. So x over 3 is equal to the cube root of y minus 5. Then we cube it, because that's our next step. So I get x divided by 3 cubed equals y minus 5. Then our last step, we add 5. So I end up with x over 3 cubed plus 5. And there's our answer. Okay, now 11. If f of 1 equals negative 1, what is the f inverse of negative 1? Here's where that key basic idea of an inverse with the x and y swapped helps. So that 1, if we were to make a table, that's our input. Our output is negative 1. To find the inverse of that table, negative 1 becomes our input, 1 becomes our output. They're asking for an input of negative 1 on the inverse, so what's the output? It's 1. Okay, seems a lot more difficult than it should be, doesn't it? Okay, number 12. So this one, we're given g of x equals negative x plus 2 cubed. Find the inverse at 8, so an input of 8. Again, an input of 8 would be the output of 8 for your original function. So there's two ways you can deal with this problem. The first is to find the inverse. Okay, to make that y, swap the x and the y, and then solve. First we divide by negative 1. So basically negative x equals y plus 2 cubed. Take the cube root. Cube root of negative x equals y plus 2. Then subtract 2, and you end up with the cube root, negative x, then minus 2 outside of that. Okay? Then you plug in 8 for x, and so you take the cube root of negative 8 minus 2. Cube root of 8 is 2. Negative stays 2. Negative 2 minus 2 gives us a negative 4. So our answer would be inverse of g of 8 equals negative 4. Okay, the other way to do it, which is basically the same concept, would be to just realize this is your regular, your non-inverse, your regular g of x output, because of that idea of the inputs and outputs being swapped. So you could do this and then solve for 8, which is the same process. The difference is, instead of dealing with an x, you're actually dealing with a number. But you end up with the same exact thing. Okay? But either way works. Sometimes it could be easier doing it one way as opposed to the other. All right. Now 13 says, just find the inverse, okay? So change that to y, swap the x and y, so x equals y cubed plus 5. What's happening to y? Well, first we would cube it, then add 5. Going backwards, doing the inverses, so we subtract 5 first. X minus 5 equals y cubed. Then take the cube root. We end up with the cube root of x minus 5 equals y. Then we just write it in function notation. So we'd write inverse of f of x equals the cube root of x minus 5. Okay, then if we look at 14, multiple ways we could decide if these are inverses. Okay, we could take one of them and try to find the inverse. So make that y and go x equals y minus 2 squared, and then see if they match up. So we'd get, take the square root, square root of x equals y minus 2, add 2. get the square root of x plus 2, with the plus 2 outside, which tells us right off the bat they're not inverses. The other way would be to say this is a minus 2 on the inside, it's got to be a plus 2 on the outside. So kind of using that same concept of solving it, but not actually solving it. Okay, and realizing they're not inverses. Okay, that would be the other way. Or we could just graph them and realize that they end up not being reflected over that y equals x. Okay? Now, 15, 16, and 17, you're just looking for pairs of inverses, okay, using tables. So once again, are the x and y's swapped? They can be in reverse order, but they have to be swapped. So let's see if A has an inverse. Okay, so we have 60, 56, 48, 44. Do we see that? See a 60 right here, 52 right here, 44 right here. But they're on the same side, so that tells me right off the bat that's not going to match up with that one. Okay, we've got another one, F. Okay, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. 60 to 44, 60 to 44. Boom, right there we have a match. So A and F are inverses. Now you may have done them in a different order, and that's all right too. Okay, so if I look at B, negative 25, 20, 15, okay, and D, same x, tells me right off the bat they're not inverses because they have the same x column. So the only other one, I, has the same thing. So it's got a 25, 20, 15, and 10, and 5, opposite the same ones, but notice they're upside down. But it's still the x's become the y's become the x's, and those same x and y pairs match up, which means yes, B and I are inverses. Okay, then C, 97531, 97531, 975, which one's in the y column? G, double check the other, negatives, okay? So C and G are also inverses. So don't let them trick you by changing positives to negatives and negatives to positive. That's not an inverse. And if the x values are stay in the same spot, that's not an inverse either. Alright, now we're going to find the inverse of each function and graph it. So first step, take this. What's happening to x? Well, because x plus 7 is on the top, I would add 7 first, then divide by 3. We solve by timesing by 3, then subtracting 7. Make that y, swap the x and the y. Times by 3 first, 3x equals y plus 7. Because timesing and dividing by 3 undo each other, subtract 7. We get 3x minus 7. So f inverse of x equals 3x minus 7. Okay, then if I were to graph them both, I have our first graph. I could graph it, right? This is our graph. I would go down to negative 7, then our slope up 3 to the right 1. Now, looks like they want the graph right here, but I think it's a good idea to actually graph it on the same one. Like that. Okay, then number 19. So that's a square right there. Change that to y, swap the x and the y. Then notice what's happening to the y. Well, first, since it's in a parentheses, you do that first, so I'd subtract 1. Then we deal with exponents after parentheses, so I'd square it. Then last we would add 2. If I'm solving, so I start by subtracting 2. So I get x minus 2 equals y minus 1 squared. Then we would take the square root of both sides. x minus 2 equals y minus 1, square root of x minus 2, I should say. Then we would add 1 to both sides. So it would be square root of x minus 2 plus 1. Okay, so f inverse of x equals square root of x minus 2 plus 1. Now, if I'm thinking transformation-wise, my square root looks something like this. And because of the nature of squares and square roots, I'd actually kind of have to do the positive and negative version of this to make it match up exactly. Okay, but I'm shifting it to the right 2 because it's minus 2 and then the inside it's opposite. So it'd shift over here and then up 1. So to the right 2 and up 1, that would be the vertex, and then it would look like this and like this if I'm matching it up exactly. Okay, so if I graph that on the same one, it would look like that. So now 20 says, what do you notice about the graphs and their inverses? So hopefully what we've talked about and what you notice here is that if we graph this line y equals x, that because we swap the x and the y, the x and y values are all swapped, which make you reflect over that x and y. So the graph is always reflected over that. Alright, so they're reflected over the line y equals x. Alright, so there you guys go. Make sure you are ready for that benchmark test, and good luck.